So this demo is to show the visitors how the aQusta Barsha pump works, and to highlight that innovation. So the presenter will start off talking about introducing the problem, what the students were trying to solve, which was that farmers in some parts of the world might be on quite hilly ground, and then there's a river quite low down, so there's water there, but it's hard to get it onto their fields and to irrigate their crops. And to do that, they either have to carry the water in buckets using a big yoke, which is obviously a lot of hard work, or they use a diesel pump to pump the water up the river and onto the slope. So a group of students looked at this challenge and ended up designing a water-powered pump. And here's a model of it. It's called the aQusta Barsha pump. And water comes along the river. This floats with these floats in the river, and it's tied in place. And as the water runs underneath it or through it, it turns the wheels. And on both wheels, you have a spiral of tubing, which fills up with water, and with each revolution, pumps a little bit more water out through the centre of the thing, and a tube hose pipe or something similar takes the water up the hill to feed the crops the water. So that's basically what this is. Now, to show you how the spiral works, I've got this Meccano model with a bit of spiral tubing. This one isn't water powered, it's just to show you how the tubing works. So I'm just going to turn this handle slowly to rotate the spiral of tubing, and I'm going to transfer some water from one of the white containers to the other. So we've got a container of water here, which I'm going to just pour now. This is just plain water. I put a little bit of vinegar in it because vinegar changes the viscosity slightly and makes the water slightly less clingy onto the tubing. Vinegar is a bit like, you can use vinegar inside a washing machine instead of rinse aid. It has the same function, helps the water run off the surface of the pots and pans. Anyway, in this case, it's going to make the water slightly more viscous. Okay, less viscous. Anyway, here's the tubing, and as I turn the spiral, you'll see that water gets picked up by the outside of the tube, and with each revolution that water spirals closer to the centre, until after however many turns it should start to come out. There we go. It's now coming out in the middle. Now the Barsha pump uses exactly the same principle as this. The water and the air that gets picked up by the tube generates quite a lot of pressure in the case of the Barsha pump, because the diameter of the wheels is so big. And it can generate enough pressure to force the water 2 kilometres inland or up to 20 metres up a slope. So there you go. Obviously this is a very small scale model, so the pressure is much less, but the principle is exactly the same. There we go. Now, one final thing, just to show you again that this obviously was powered by me turning the handle, but the actual Barsha pump that the students invented is a water wheel. So the water itself turns the wheel like this. When you're packing away the partial pump demo, don't try and lift up the tray and pour it into the bottle because it'll go everywhere. Use the measuring jug and pour it in with that. And if you pour it around this way, any drips from the bottom go back into the tray. And also, it's worth having a tea towel to dry off the Meccano and the trays before you put it back in the trolley.